The observations of systematic thermal motion of molecules in water were carried out to investigate the mechanism that forms the organization of molecules by itself. Part 1. At first, as an attempt to observe the thermal motion of organized water molecules, carbonated water was frozen. Because the motion of bubbles in the melting state of carbonated water will be seen. The ice of carbonated water forms tunnels of bubbles similar to spiny of a sea urchin. Characteristics of carbonated water. Carbon dioxide dissolves well in water. But 98.3% of carbon dioxide is that form of molecule. The entropy of the carbonated water is reduced to that of pure water. Mechanism of carbon dioxide hydrate. The structure of water aligns molecules of carbon dioxide, and the carbon dioxide aligns molecules of water. The arrangement enlarges the intermolecular force. In a similar mechanism, cluster of carbonated water will become large. The movie shows a melting ice of carbonated water. A unit of the thermal motion of water is a visible size. Long-range force of water molecule forms a cluster. It has effects on systematic motion of molecules in liquid water also. The cluster of water is an intermolecular organization, where water molecules are bonded partially in the water. It is considered that carbon dioxide molecules are trapped in the gap of the lattice structure in the cluster. From temperature dependency of the evaporation energy of water, the activation energy of melting ice is 1.4 kilocalorie. But that of water is 10 kilocalorie. The difference in energy between ice and water is small. Activation energy of dissolution of carbon dioxide in water and activation energy of water is approximately equal to the activation energy of hydrogen bond 5 kilocalorie. This fact means the solubility of carbon dioxide depends on the intermolecular force of water. The lattice structure of the hexagonal will lost at higher temperature of Celsius 60 degree, and the solubility of carbon dioxide becomes 0. A molecule of water is arranged as a tetrahedron unit. Electric dipole of water molecule is arranged along the electric axis of 3 directions. There is a penetrating hole along the optical axis of each helix that is perpendicular to the direction of electric axis. Owing to the hydrogen bond, the structural unit of water in liquid water is deformed a little from a regular tetrahedron. The activation energy of rotation along electric axis is small. When the tetrahedron molecule rotated at deviation of 90 degree, the energy will be peak. When the hydrogen atom pair appearing in a through hole is rotated in the same direction around the electric axis, a flow in one direction takes place at the through hole. If the adjacent tetrahedron rotates alternately, the flow along optical axis will be aligned, and a flow of macroscopic size will occur. Part 2. The next videos show the thermal motion of cluster on the processing milk that had been diluted 100 times with water. Brownian motion of size of 10,000 angstroms in water is not due to random motion of size of 3 angstroms of an individual molecule. The Brownian motion is linked with thermal motion of the cluster. The magnification of following video was objective lens of 40 times, eyepiece lens of 20 times, a digital camera of optical magnification of 5 times. There are cluster of water thermal motion around the fat globules. The Brownian motion of a fat globule is slow, because it accompanies with cluster of water. The magnification of following video was oil immersion objective lens of 100 times, eyepiece lens of 15 times. This observation uses the diluted processed milk that had made 3 days before. The specimen stage is lowering down slowly. Thermal motion of the particle at an interface is very slow, but the effect of fixing will decrease at the inside of the liquid. The flicker noise of this digital camera is observed at outside of the image of microscope. Since shutter speed of digital camera is faster than eyes, we can see a movement clearly through digital camera. The specimen stage is lifting upward slowly. Fine particles are moving around a fat globule of milk. The magnification of following video was objective lens of 10 times, eyepiece lens of 20 times, a digital camera of optical magnification of 5 times. There is a weak linkage among the thermal motion of individual cluster. Intermolecular forces have effects on the thermal motion of the molecule of water. The synchronized activity plays an important role for the metabolism of a creature. This movie shows the thermal motion of water on the ice of carbonated water, in order to recheck the thermal motion of liquid water. The thermal motion of molecules in water is rotational type of complex. This video reported the mechanism of the thermal motion of molecules in water. As concluding remarks, the thermal motions of cluster of water were observed. The behavior of molecule in the water will reveal the origin of biochemical reactions in a creature. Thank you for your attention.